Greetings. So today's class in embedded programming, we'll see the introduction to embedded C. So what is embedded C? Embedded C is an extension of the C programming language designed specifically for programming embedded systems and microcontrollers. So when you work with embedded systems and microcontrollers, you prefer to work with C, and that is specifically embedded C. So looking into the characteristics of embedded C, it is used for hardware programming. That is what for embedded programming. It executes directly on the microcontrollers, so you need to have microprocessors or microcontrollers for that, and the memory utilization should be efficient, the execution is fast, and supports real-time applications. Whenever you look into the embedded applications, it should be of real-time applications, mostly, or real-time applications. So some of the applications are washing machines, microwave ovens, automotive ECUs, medical devices, smart home appliances, IoT devices. All these things we have studied in the earlier classes. And what is the main difference between embedded C and its standard C? When you look into the standard C, they run on computers and they are used for general purpose, and larger memory will be available, and the operating system support you need to have, and uses standard libraries, and you will need to have a keyboard and a monitor and input-output devices. While on embedded C, it runs on microcontrollers. This is mainly for embedded applications, so it's hardware-specific programming. The memory constrained devices, it should run on memory constrained, so the memory is limited, usually no operating system. In case if it's it may be dependent on an RTOS, real-time operating system, and uses the hardware libraries. It makes use of input-output devices like general purpose input-output, UART, ADZ, PWM, timers, etc. And what are the features of embedded C? Looking into the important features, it's portable language, whereas in case of an assembly you will not be able to compatible. It's not compatible. That is, when you write an assembly language program, it may be working for one processor, and when you want to switch over, it's not easy. You need to rewrite, and again you have to do it. Instead we prefer to go with embedded C. So when you write for one process, if there is a upgradation, or if you want to switch over, it's for some small changes, you can go for a compatibility. We can change that for the other processor. So structured programming, you will have this is a way you should write, and there is a modular programming. It's hardware register access. You can access all the registers of the hardware devices. All bit manipulations can be done. Interrupt support is possible. An efficient code execution, small memory. And what are the advantages? It's easy to learn, high execution speed, reusable code. That's why I said you can change this code with simple changes, so that you can support many applications, embedded applications. So when you look into the structure of an embedded C program, you can see, as I've given in the slide, you have include stdioh.h. It is a preprocessor directive. This is a header file. You are including all the required header files. And again, this is just an introduction part today's class, and in the next classes we'll be seeing all these things in detail. The structure of an embedded C program itself you will be seeing in detail, and now just an intro part to the embedded C program. And you have a void main. Which represents the starting point of the program. Then you can see something as variable declaration. So whatever you need to have, suppose if you want to have a one memory location, you can declare. Whenever you want to have two memory location, you can declare. So it shows all the program data. So that's all declaration can be done. And you have something which is called as initialization. This is a location where you are going to initialize or configure all the microcontroller and the peripherals. Whether you are going to configure a port as an input, whether as an output, or how many, whether you are going to get some input, initialization, initial data, and you are going to move the data to somewhere else. All these initialization or the configuration has to happen in this area. And so inside main, you need to have declare the variables, and then you go for initialization. Then you can see in all embedded C programs, you will have a while of one statement, which means that you want to run the program continuously. That is, in case of embedded C program, if you want to run it for a one time, you need not have this term. So but this, it goes with continuous operation until some kind of situation rises. So this keeps the program runs continuously. So you'll have while of 1, and then comes the application code. That is, inside the braces of while of 1, you will have the actual embedded task, whether to switch on an LED, whether to light switch on an output, or any kind of audio, anything, whatever you want to do. You want to on and off the LED, you want to switch on a buzzer, whatever application that's given will be written in the application code. So you have some data types and variables. To make you understand at the outset, I'm just going to say what are the data types that's available. You have char, it's again 8 bits, that's a 1 byte. The next is int, which is 16 bits, and float, that is 32 bits. Double, it's again 8 into 8, 64 bits. Unsigned int, it's again 16 bits, right? And again you have some kinds of variable types. Whenever you declare some variables, you may declare it as local, something as global, and something which is called as static, and this volatile, and something which is called as a constant. So all these point by point we will be studying in a later classes. And you have some operators in embedded systems. So whenever you want to have some kind of variable declaration or some equations or anything, whenever you want to perform any operations, you need to have operators. So these operators, some of these operators are arithmetic operators, so that when you use that symbol, it will can add or subtract, it can do anything. You have relational operators, logical operators, and or all kind of logical operations can be done. Assignment operator to assign some values, increment and decrement operators, bitwise operators, conditional operators, and the size of operator, and address and pointer operators. All these operators again will be seeing with examples in detail in the later classes. This is all to introduce some these topics to you. So this kind of operators are available in embedded C. Thank you.